Hi, my name is Rodrigo, and I'm going to explain how to solve a trickier problem involving a system of equations. So the problem reads, if the graph of the lines in the system of equations above intersect at coordinate 4, -1, what is the value of b over a? A and b are unknowns found in the system of equations alongside x and y. So if we consider the system of equations by itself, we would have four unknowns: a, b, x, and y. And the fact that you would have four of them would prevent you from using the elimination method or the substitution method from solving the system of equations. The reason being is that both methods require you to have the same number of unknowns as distinct equations. So if we have four unknowns, we would require four distinct equations. In our case, however, we only have two distinct equations, meaning that we have to reduce the number of unknowns. You can do so by recognizing that we already have the solution to the system of equations in the form of the point of intersection. Now, to reiterate, the purpose of the elimination substitution method is to find the solution. In this case, we already have that solution in the form of x is equal to 4 and y is equal to -1. Now, why do I know that the point of intersection must be the solution of the system of equations? Well, let me explain. So, if you consider two intersecting lines and the point of intersection between those lines, we of course know that the point 4, -1 lies on both graphs. And the relationship between the points on the graph and the equations of the graph is that all points that make up the graph must be solutions to the equation of the graph, such that when you plug in the x and y value from the points, the left-hand side of your equation will always equal the right-hand side of your equation. So in our case, for our two equations, since we know that the point 4, -1 lies on both graphs, when we plug in x is equal to 4 and y is equal to -1, then the left-hand side must equal the right-hand side with those values plugged in, and that allows us to solve for a and b. So let me go ahead and show you how to solve for a and b using that information. So you plug in x is equal to 4, you get 4a, and then -1 for y, minus 2 times -1 would be the same as adding 2, which is equal to the right-hand side of 18. Subtract 2 to the other side, you get 4a is equal to 16. Dividing by 4, you get a is equal to 4. Now for the second equation, you again use the same x and y value. So you get 4b when you plug in 4 for x. 6 times -1 gives you -6. So adding a negative number is the same as subtracting that number. So 4b minus 6 would be equal to the right-hand side of 26. Add 6 to both sides, you get 4b is equal to 32. Dividing 4 to both sides gives you b is equal to 8, which allows us to get our final answer. So recall that they asked us to solve for the value of b over a. So given our values here, you would do 8 divided by 4, which is the same as 2, giving us the final result of d for the correct answer. So now that we've solved this problem, you can see that this problem takes the typical setup of a system of equations and adds a conceptual twist. So this system of equations is actually pretty cool in the sense that you have two distinct equations that solve two atypical unknowns in the form of a and b. So normally you would solve for x and y, but x and y here, as we saw, aren't actually unknowns, they were given. So we did solve two unknowns, a and b, again being atypical for this type of problem. But regardless of how cool you normally find math, I look forward to meeting you and working with you.